Hello, Chad Kirdy again. This is part 4 of Introduction to the National Electric Code. This part we're going to zoom into the definitions, Article 100. You will not understand the National Electric Code unless you understand first certain definitions in the NEC Code book. I will be highlighting certain things, and I depend on you to go back and read them as you move and to understand what's going on in the NEC Code book. So I want to start in Article 100. You'll have the definition of all the terms that used globally in the NEC Code book. Globally in the NEC Code book, I highlighted a few of them for you. One thing I'm going to go and zoom right into here. One thing I'm going to highlight over here is the authority having jurisdiction. This is your electrical inspector that's going to be inspecting your work. You must understand the authority having jurisdiction. Who is the authority having jurisdiction? Another term, and I'm going to just slide another term, the ampacity. When I say number 14 conductor cannot carry more than 15 amps. That's the amount of amps that the number conductor can carry under certain conditions, normal conditions. When I say this conductor can carry only 23 amps, this means I cannot exceed that 23 amps. Very important, the ampacity, how much current you can push through a copper or aluminum conductor. Extremely important. Two topics, and the second one I'm going to highlight here. Oops, here you go. And the second one I'm going to highlight is right through important topic is arc fault circuit interrupters. Arc fault circuit interrupters. And so arc fault circuit interrupter is brand new in 2008. Well, it has been for a while. But if you have an arc in a circuit, these are electronically designed equipment that senses that there's an arc and interrupt. So if you can see a device intended to provide protection from an effects of an arc fault. An effect of an arc fault. So that's, you're going to hear that there is receptacles in a bedroom and residential need an arc fault. So you have to find what the heck is an arc fault. A circuit breaker that trips in case of an arc. Line to line, line to ground, that circuit breaker will trip, or that device will trip. Moving on into a couple of other things that I will define for you here. I asked to highlight. In this page, I have a branch circuit and branch circuit multi-wire. We talked before about branch circuits, so now we're going to define a branch circuit appliances, branch circuit purpose, a branch circuit individual, and branch circuit multi-wire. Branch circuits, if I have a circuit coming from over here all the way to my nicely laid out AC system. This is a dedicated individual branch circuit. So this was a 30 amp, and this was number 10 conductor. Number 10 conductor. That's a branch circuit for the conductors between the last overcome protection device and the utilization equipment. Branch circuit appliances goes to an appliance. Branch circuit general purpose feeds multiple lights and receptacles. Branch circuit individual supplies only one utilization equipment. Branch circuit multi-wire. If I have a multi-wire branch circuit, say I have 2 rows of lights over here. Here's a multi-wire branch circuit, 1, 2, 3, and I have a neutral right with it, and I have multiple lights, and these lights are fed from, so I have 3-phase, 3 hot conductors tied together, 20 amps, and I have a neutral. This is phase A, phase B, phase C. 3 phases, common neutral. That's what we call it, branch circuit multi-wire. Very important to understand it. So 2 hots or more with a neutral. So that's very important to understand that concept. Moving on with the definitions. Branch circuit. I have disconnects. I have 2 I want to highlight over here, and all of them are important, but I'm just highlighting the most important. And energize. Energized. So I have an energize. And disconnect means is meant to isolate completely the equipment so you can do some maintenance on it. So you don't, when you stick your fingers to go clean something, your fingers will come back with you. Otherwise, if you don't have isolated disconnect, that machine could be energized remotely. So that disconnect is completely isolated the system. Disconnect means Energized, electrically connected to, or, so if you have, when we say energized, means hot, means there is a juice sitting there to be consumed if you close that circuit. That's phase A, phase B, phase C, hot 1, hot 2. We call them energized, hot, energized, hot. So these are terminology you have to be very aware of when it comes to the NEC Code book. Moving on to a couple of other very important topics too. There you go here. Right here. Finally, we defined what the ground is. In the past, we didn't know what the ground is. Now we know it's Mother Earth. Ground is connecting to Mother Earth. Now we know that. Ground fault, if you have a ground fault, is unintentional. Ground fault, unintentional, connecting between a hot and a grounded object. A hot and a grounded object. Very important when you hear a ground fault. Grounded conductor. Grounded conductor. A grounded conductor. And I have also for you a ground fault protection and ground fault circuit interrupter and ground fault. So grounded conductor, this is my neutral conductor. Everything is in the code is defined by the ground. We have the ungrounded conductor, these are the hots, phase A, phase B, phase C. Grounded conductor, these are the neutral. Grounding conductor, that's the ground. So these are very, very important. A ground fault circuit interrupter, specially designed piece of equipment that look at the current that goes through the hot and the neutral and trips. Very important to understand the definition of GFCI. We need GFCI in the kitchen, GFCI outside. So that's very, very important to understand what a GFCI is as you go through the NEC Code book. As you go through the NEC Code book. Equipment, I'm going to, moving into the ground, I'm going to move directly into ground. Two topics here. I need grounding conductor, grounding electrode, these three topics. Grounding conductor equipment, grounding electrode, and grounding electrode conductors. These are very unique, specific, different type of grounding system. So grounding electrode conductor, grounding conductor equipment, or equipment grounding conductor, that's the grounding conductor that ground the equipment itself. A fan, a receptacle, a light, ground equipment. A grounding electrode system, that's a conductor, that's a means to connect the system into the Mother Earth, or a conducting object through which the direct connection to Mother Earth is established. That's a rod, a pipe, a ground rod, a rod or a pipe, a water pipe to connect to it. A grounding electrode conductor, that's a conductor that you tie your system directly into the ground. You tie your system directly into the ground. So these are very, very important topics. So if I have a 200 amp panel without getting into grounding, this is my neutral, this is my ground, and I take from the ground directly here to Mother Earth, to a rod here, to that conductor here to the rod is going to be my electrode. Is going to, the rod here is going to be my electrode. And grounding electrode conductor, that conductor right here is going to be my grounding electrode conductor. And if I have a machine that's tied, here's my fan, 5 horsepower motor connected to the system, and I need to ground my fan. Grounding my fan here, this conductor here is called equipment grounding conductor. It's called equipment grounding conductor. 3 different unique terminologies that we use with grounding. 3 different unique terminologies that we use with grounding. Moving on, and grounding is a big topic, and will be covered in details later. Very important things I have in this, labeled and listed. Every equipment that we install in the NEC Code book, they always use labeled, listed, have a label on it like UL label, and listed being listed in a list, meaning it's approved for the use. I have a fixture, wet location fixture, listed by UL as wet location, have a label on it as wet location, and also in a list provided by UL as a wet location. So that's very important, listed and labeled, to understand as you go through. A couple of other things also here. Location, dry and wet location. Very important to identify the place as a dry location. Location dry means I can use any fixture in a dry location. Wet location, obviously there's water, always. Water, so I cannot use a fixture that's rated for a dry location in a wet location. So you're going to hear a wet location versus dry location. These are where you can find the definition of a wet and dry location. Moving on into a couple of others that I would like to highlight. And again, everything is important here. Everything is important except we're going to highlight certain things. Service entrance conductors. I have one more here. Overcurrent protection, supplementary overcurrent protection device. Overcurrent protection device, these are the fuse or the circuit breaker that will interrupt a short circuit or a ground fault in your system. That's how we define it right in here. It's basically feeder branch circuits or that can interrupt in the case of a short circuit. Your circuit breaker of the fuse will melt or the circuit breaker will open. That's how you find a definition of an overcurrent protection device. Overcurrent protection device. I'm going to go all the way to my service conductors. Brand new in 2008. Brand new in 2008. The power is coming to you. There's a few definitions that's really interesting to know. Wonder if I can go up a little bit here. Okay. These are extremely important definitions from the service conductors overhead to coming with service conductors underground into service drop, into service entrance conductors, into service entrance conductor underground, and all the way to service equipment. All these are related to bringing the power, the conductor, directly from the transformer of Excel Energy or any other power utility directly to your building, directly in your building. Service conductors overhead. These are coming from the overhead conductors between the service point, very important term, and the first point of connection to the service entrance conductors. Underground doing the same thing except now is coming from underground. Service drop, that power line that's coming to your building, service drop. Service entrance conductor, these are the conductor that goes through your meter, disconnect all the way to the first panel. And very important to know, entrance conductor underground, service entrance underground, these are the same thing coming from underground. Service equipment, this is the first piece of equipment that you bring the cables in and you land them in the terminals of that equipment. That will be called the service entrance equipment. It's a panel basically with a circuit breaker on it. So these are terminology as you go through chapter, through the service, the article that talks about service. You cannot understand it without knowing all these terminology. And again, I can't emphasize the importance of reading and going through them. I'm going to go over, show the service point. Service point is very important, very unique. A lot of people, guys, miss it. Service point. This is tiny little. This is established between you and the utilities. The utilities have to say, this is the demarcation point between your building and my cables. So it's a demarcation point where the utility bring their cables and you bring your cables and you tie them together to bring power to the system, Very important, because that will decide what's your territory versus what's the jurisdiction and territory of the electrical companies. So that will be very helpful. And a few other things that I would like to highlight is voltage nominal. You're going to hear the term voltage nominal, and voltage to ground. Voltage nominal, it's an assumed. If you say voltage nominal 208, 120, it's a nominal voltage. If you go measure, it might be less or more than voltage nominal. So this is very important. These are just an assumption voltage, not actual voltage. The actual voltage could be less or more. Voltage to ground in a grounded system, it's between the hot conductor and the grounded conductor. And the last thing, and also voltage of the circuit, is the RMS value. That means a whole lot as you go through the NEC Code book. And the last thing in this is if you are to deal with higher voltage, 13,800, if you're dealing with 13,800 kilovolt, there's a certain definitions in the NEC Code book related to high voltage, anything higher than 600 volt, anything higher than 600 volt. So that article, there's electronically actuated fuses and so forth. This place is not for it, but if you are to deal with medium voltage, this is a place where you can discuss it in details.